So hey Mr. Caden, this video is for you. For anybody else watching, Caden's my grandson. I'm giving him this book and a cube, and this video is going to be a demo of how to solve it. This is kind of a cool book though. It's about a little kid, Andreas, who learns to solve from his friend Kino. He gets super into it, learns to actually solve it, starts studying algorithms, goes to competitions, has his cube explode. We'll take apart a cube in a few minutes here. And he's a real kid though, actually, Andreas. He actually went to, this is from Nationals in 2017. This was his first solve actually, 15.25 seconds. Pretty ridiculously fast. This book was written by his mother. Maybe you can read it to your mom. And so then I'm also going to give you this cube. This is a pretty nice cube, a GAN Infinity. It's half bright colors, magnets, lubed. You know, it's pretty smooth and nice. Hopefully you can have some fun with it. It'll probably last you 10,000 solves. And let's get going. So maybe you've started playing with your cube, and if you're lucky and you're persistent, maybe you've actually solved one of the sides. But one thing to realize is that since none of these edges are correct, this isn't really solved. We're not solving colors, we're solving pieces. And these pieces aren't in the correct place. So I'll show you what I mean. When I was a kid, I used to take apart all my toys, and I still do as an adult. So let's take these apart. We can see that there are corner pieces that have three colors that are attached that can't move relative to each other. They're always stuck this way together. Or edge pieces that have colors that are stuck together. This blue has to always be next to this red. Now there's other kinds of blue edge pieces, but for example, you will never find a blue-green edge piece, and I'll show you why. Let's finish taking this apart. Comes apart pretty easily. Actually, it's kind of funny, some of these pieces stick together because of the magnets. So even with it apart, you could probably build a cube without the centers. Here's the centers though. This is how the cube really works. It's center color pieces that are stuck, screwed right into a center core, and they can rotate around that core, and then all the pieces that are packed in there are just held in by these springs and can rotate around. But these centers don't actually move relative to each other. They spin in one axis only. So for example, blue and green are always opposite, and that's why you'll never find a blue-green edge, because there are no edges that are next to each other that are blue and green, because those are on opposite sides of the cube. Orange and red are also opposites, and white and yellow are always opposites. They'll always be. So you need to start thinking about, instead of solving for colors, you're solving for pieces. And the pieces are identified by the colors. You know, this is the green-orange edge. There is only one edge that is green-orange. So you can call this the green-orange edge. But what matters is that this piece belongs in a certain place. In fact, it belongs, it belongs right here between the green and orange centers. Let's see if we can do some other things. Like this corner belongs right here between the orange, white, and green centers. And that's what you're actually solving. So it's kind of fun to take toys apart, and it's kind of fun to understand how the cube actually works inside. The first step of Roux is to complete this block on the left side. These 6 pieces all together makes the first block. That's the first stage. The second stage of Roux is just like we built this first block in blue on the left, we build a second block in green on the right. The third stage of Roux is to solve these 4 corners on top, which leaves just these 6 edges and the centers that go between them. And that's the fourth stage of Roux. Then the cube is completely solved. The first thing that we want to do is to find this blue-white edge somewhere on the cube. And we'll just rotate the cube so that the white is facing down and the blue is to the left. So now before we've even twisted anything, we've solved one piece. Next, we'll find the blue center that goes with this blue-white edge and put them together. It's pretty simple. If it happens to be in this middle slice, if it's on top, you can just bring it down and over. And if it's on bottom, you can just bring it up and over. Now we have 2 pieces solved. Then we're going to search around the cube trying to find this blue-orange edge piece. It could be hiding anywhere. And what we want to do though is bring it to the top and rotate it around and bring it down to this front down position. Now it doesn't matter whether the blue or the orange is facing forward. It could be flipped around. That's fine. We just want this piece to be here. Now this piece actually belongs back over here, but we're going to use this strategy of storing it here temporarily while we go and find the corner that it goes with, pairing them up and putting them in together. So now this blue-orange edge goes with a blue-orange-white corner piece, which could be hiding anywhere on the cube, and what we want to do is bring it to the top. But we don't want white to be facing up, so if that happens, just do something to get orange or blue on top. Then the idea is to line them up and make a pair. And then this pair belongs back here, so we can just rotate it around and insert it. That's the idea. Now we have these 4 completed. Now, the same kind of idea, we want to find the blue-red edge and move it here. Usually easiest to move it to the top, spin it around, and bring it down. So now that's in place. And just like before, we're going to search around the cube for the blue-red-white corner and bring it to the top. Blue happens to be up, which is great. We just don't want white to be up. And then we can line these up, make a pair, and insert it. So now these first 6 are complete. This is the first block of Roux. Now that we have the first block built, the next thing we're going to do is do the same thing on the right hand side with a green block. Now because blue and green are opposite, the green center is automatically solved for us. We just need to find the green-white edge that goes with it. It happens to be hiding in the back here. It's easiest to bring it to the top and then line it up and put it in. Now if somehow the green edge had been flipped, so that when you try to line it up it doesn't work, the easiest thing to do is to just move it over and move this entire side to flip it again and line them up, put them down. Now these 2 are solved. Then like before, we'll start solving the pairs that go along here and here. We first want the green-orange edge, which happens to be hiding in back here, and we just want to bring it to the front. So that was quite easy. We want to make sure that as we do these things, we don't disturb these 2, and we don't break the work that we put into building this first block. Then we'll go ahead and find the green-orange-white corner that it goes with. Could be hiding anywhere on the cube, and we want to bring that to the top. Something like this. For one, we don't want to disturb this, so we'll move that out of the way and put it back. And secondly, we don't actually want white to be the up color, so we'll need to do something to flip that again. And again, move it out of the way so we can put this back. Now that this is on top, this kind of alignment doesn't work because it's flipped, but they pair nicely in the back. And luckily, they actually belong in the back, so it's easy to insert them there. And now these 4 are done. Now we'll find the green-red edge right there. Now again, it could be anywhere on the cube, and it's up to us to just move it around and place it in front here, still without disturbing this or this. Then finally we find the green-red-white corner, which is running out of places for it to hide. That's actually why we do these back pairs first, is so that there's fewer places for these things to hide that you don't have visibility to. So this guy's just on top already. It's pretty easy just to line it up and insert it. And now the second block is done. We finished the second stage of Roux. So for the third stage of Roux, we're going to solve these 4 corners. We're going to do it in 2 steps. So first we're going to twist them all so that the yellows are facing up on top. And then we're going to move them around so that they're in the correct positions also. Now all of the corners that have yellows, like this one, this one, this one, and this one, they're already on top. And that's because the bottom is the white ones and they're already solved. Now the rule is, if there's one that's facing up already, then we put it in the bottom left corner. And then we do an algorithm called the soon. And I'll show you how it works, and maybe you'll have to write it down. Eventually it'll be in your muscle memory and you won't have to think about it. But what you do is turn the right clockwise, then the upper face clockwise, then the right counterclockwise, and the upper face clockwise again. Then the right clockwise, and the upper face twice, and the right counterclockwise. And that just oriented all of those corners. Now, depending on the exact case, you may have to do that soon algorithm more than once. So here again we have one that's facing up, so we'll put it in the bottom left corner, and we'll do that soon algorithm. But it didn't solve it. We still have one. So we'll put it in the bottom left again and do the algorithm again. And that worked. So sometimes you have to execute the algorithm multiple times. Sometimes you're not lucky enough to have just one facing up on top. Sometimes there's two. And in this case it's a different rule. In this case we'll find one of the side yellow edges and we'll move it so that it faces the front on the left here. This one can't be done, but this one can. So we move it so that one of these side yellow edges is facing forward, and then we do that soon algorithm. And just like before, it didn't work in just one step, so we'll do it again. And it still didn't work, so we'll put this to the left, and we'll do it once more. So it always works eventually, it just takes multiple tries. Sometimes even there are none facing up, and so that still uses that second rule, where we'll take one of these side ones and make it face forward on the left, and then do the soon algorithm. Now we have two, and so we take and move one of these side to the left. That didn't complete it, but we'll keep this one in the bottom left corner. Do it again, and it still didn't complete it. So we'll move that one to the bottom left and do it once more, and that worked. So now that we have the top corners oriented so that the yellow is facing up, we need to now move them around so that they're actually solved. It turns out these two are solved. I can show that by moving them into place. But then these two are not. So when that happens, what we do is we put these two that we have solved on the left-hand side, and we need to execute a new algorithm. It's called JPerm. And I'm sorry, it's a long algorithm. There's not much we can do about that. It's the easiest way to do it. These algorithms, you'll probably need to write them down at first and then just practice them over and over until it becomes muscle memory and you don't even have to think about it. I'll show you how it goes. You start out turning the right face clockwise, then the upper face clockwise, and then the right face counterclockwise. So far this is actually the same as soon. But then you do the front face counterclockwise, the right face clockwise, the upper face clockwise, and then the right face counterclockwise. Then the upper face counterclockwise, the right face counterclockwise, front face clockwise, right twice, then the upper face counterclockwise, and the right face counterclockwise. And that has solved all four corners. We can rotate this around to show it. Everything is perfectly in place, and that is the third stage of Roux. Every once in a while you'll run into a case like this, where as we look around, none of them are solved actually. All of these pieces need to be swapped. In fact, these need to be swapped, these need to be swapped. So in that case, it's just like with the soon, where you have to execute the algorithm a couple of times to get it to happen. This time, we just don't worry about what's on the left-hand side, and you execute that JPerm algorithm. And you'll need to memorize this, but that will cause at least one of them to be paired in front now. Now the others are not still, but we can take this one that's solved and put it on the left, and then do that JPerm algorithm once more, and it's definitely solved now. Notice now that we've finished the third stage that we're pretty restricted to what we can actually move without messing up what we've done. We can move this all we like without messing anything up, and we can actually turn this 90 degrees and it also doesn't mess anything up. So we can do any kind of moves like this. This is upper face and middle slice moves. The fourth stage of Roux is to solve the remaining 6 edges and the centers that go between them. We'll break that into 3 steps though. First we'll orient the edges, then we'll solve the left and right, and then we will solve the remaining 4 edges. Starting with orienting, the idea is that all of the edges need to be either yellow or white facing up. So these are definitely oriented, and these are definitely oriented. But confusingly, this is also oriented, even though there's one white here. It doesn't matter that it's white. And there's one yellow here. It doesn't matter that that's yellow. It wouldn't matter if the centers were flipped either. This can be white on the yellow face. It just matters that there's white facing up or yellow facing up, and white facing down or yellow facing down. None of them are on the sides. That's the idea of edge orientation. So here's an example. This is not oriented correctly because it's not white facing up. The white is facing out. This one also is facing out instead of up. This one's facing out instead of up. And on the bottom, this one's facing out instead of down. So these four edges are not oriented. Now this is a special case, this so-called arrow. If you point this arrow towards yourself and you do this simple maneuver, we won't really call it an algorithm, it's very simple. It's just the middle slice, and then the upper face counterclockwise, and the middle slice again. That orients everything. So even though this is white on a yellow face, that's still considered oriented. All the outward facing edges are not white or yellow, and the whole bottom is solved. Now, just like the Soon and the J-perm algorithms, it doesn't always work on the first try. So here is an example of an arrow. If we point it at ourselves and do this middle slice U counterclockwise and then middle slice, that didn't actually orient everything. These two are still wrong. In this case, we tend to move them towards the upper right side. So I'll move this to the upper right side and do the same thing again. And that ends up making an arrow again. Point it towards myself and do that again. And now these are all oriented and these are all oriented. All of the sides are not yellow or white. Every once in a while, you might run into a case something like this, where doing this trick of middle slice, upper counterclockwise, middle slice again, doesn't do anything. We can just keep doing this all we like, and we keep getting the same pattern on top. So what you do in this case is just turn it the other way and try it again, and now you'll get something different. And this is one of these cases we want to put to the upper right, so we do that, and now we have an arrow, point it towards ourselves, do it again, and everything's oriented. The next thing we're going to do, now that we have everything oriented, is we haven't been worrying about the colors of these edges. That's why they're just in black. But now there's two that we do care about. We want this blue-yellow edge that goes here, and we want this green-yellow edge that goes there. If we're very lucky, they happen to be on the bottom already. And in that case, we can just line this up so that these are opposite, and then they slide into place here and here, and we can just put them in place, and that solves all of this and all of this. If we're not quite so lucky, we end up finding them both on top and they're opposite sides from each other, and in that case we just put them on bottom and then do like we did before to slip them in place and solve them. It's really the same case if we find them on top and they're on opposite sides to each other, but they're actually paired with the wrong side. In that case, we just turn this, put them on bottom, flip this around, and put them back, and then they're solved. Another case that you might run into is when both of them are not on top, just one of them's on top now, the other one is on the bottom. In that case, the bottom one will be either here or here, and you move this one to the opposite side. So now we have one in the front upper face and one in the back lower face. Then the idea is to just twist this 90 degrees so that now one of them is pointing up, the green one, and one of them is pointing down, the blue one. And then we can just rotate this twice to stack them. So here's one here and one here, and then put them on the bottom. And then now it's just like the cases before where we have it on bottom, and we can just line this up and solve them. The final kind of case that you'll run into is when both of them are on top, but they're not opposite to each other. Instead, they're next to each other. In this case, all we need to do is move the middle slice twice. That will put one of them on the bottom. And then like before, we'll take the other one and put it opposite to it. Then we'll turn it 90 degrees, that one is pointing up and one is pointing down. And then we can stack them. So there's one and one. Put them on bottom, line this up, and solve them. So we're on the home stretch now. We have the entire left face complete and the entire right face complete. All that's left is this middle slice, and we can turn that all we like. One thing we don't want to do is to just do a quarter turn of the upper face and then start doing middle slice moves, or we'll break this left and right that we've finished. So we're kind of restricted now to just two kinds of moves. One is this middle slice move, and one is to change the upper face by 2. We can do that all we like, and luckily enough, we can actually solve everything using only those moves. There are much more efficient ways to actually do this phase, but just to keep things simple, we'll just stick to doing the only 2 moves we have available. Doing an M move, and then a U2. An M move, and a U2. And just keep doing that until you see a pattern something like this, perhaps, where all of these are connected, and in the back there's a solid bar. Anytime you see something like that, this solid bar somewhere around the middle slice, you can put it on top, turn it around, and then the cube is solved. Alright, so let's do a complete solve with a regular cube, and hopefully you can follow along. We'll start with white facing down and blue to the left. Just twist the right side, rotate the whole cube in your hand, twist it again, 3 times, 4, 5, 6, 7, 8. This isn't a real proper scramble, but it's easy enough to do, and now you can follow along. We want to find the blue-white edge, and we want white facing down with blue to the left. So now before we've twisted anything, we can say that we've solved this piece. We want the blue center that goes with it, just hiding in back, and we can rotate it around. Now these 2 are solved. Next we want the blue-orange edge, which happens to already be where we want it here in front. And it goes with the blue-orange-white corner, which also, by luck, happens to be on top. We can line those up, make this pair, and it belongs back here. Now these 4 are solved. Next we want the blue-red edge, which also by luck happens to be where we want, and it goes with this blue-red-white corner. Now in the future, once you've done some solves, you'll get better at this. You might notice things like this have pretty simple solutions to insert them. But for now we'll stick to our general strategy of getting this corner on top where we pair them and then put them in. So we want this corner on top, but we don't want to just do that because that moves this piece. So we'll move it out of the way, move that corner to the top, and move this back. A lot of times you have to do that kind of thing while solving, move something out of the way so you can move something else and then have to put it back. These can be paired up and back like that, and they go right here. And now this block of 6 is complete. This is called first block in Roux. It's the first step. The next step is the second block. We'll do the same thing with green on the right hand side. Now because blue and green are opposites, the green center is already solved for us. We just need the green-white edge that goes with it. You can move that to the top and line them up and twist it around to the bottom. And now these 2 are solved. Next we want the green-orange edge, which will move to the front position, and it goes with this green-orange-white corner. We don't want white facing up though, because it's not possible to pair with that way. So we will twist it. But again, we don't want to mess this up. So we'll move that corner out of the way and put this back. So the whole time we want to make sure we don't destroy this, and we also want to make sure we don't destroy all the work that we put into building this first block. Now where these are can be paired up nicely in back, and they actually belong in back here. So we can just slip them in. And now these 4 are complete. Next we want this green-red edge to be right here, and it goes with this green-red-white corner, which white again is on top and we don't really want that. So we'll twist it, move it out of the way, and put this back. And now these can be paired here, and they belong in front. And now the entire second block is done. That's the second stage of Roux. The third stage of Roux is to solve these four corners. We'll break that into two steps. One is to make sure that the yellows are facing up on all of them so that they're oriented, twisted correctly. And then we'll move them around so that they're in the right positions also. So first, to orient them, if there is just one yellow sticker facing up, it goes to the bottom left, but otherwise, and that's the case here, we don't have just one, we have two. We will take one of the other yellow faces and have it face forward in the left position. And then we do the soon algorithm. Now we do have just one facing up, one corner, we don't count that one. And so it's in the bottom left corner, and we do the soon algorithm again. Now again, we have just one facing up, but it's in the wrong corner. So we'll put that here, and we'll do the soon algorithm again. Now all four are oriented, but they're not in the correct positions yet. These two are right, so we'll put them on the left, and we'll do the J-perm algorithm. And now they're all relatively solved. We can twist this just to prove that these are actually all solved properly. Next, we want to orient all of the edges, and we can do that by starting with the centers. This orange is wrong. It should be white or yellow. We'll just do that. So now that center is correct, and actually all of these edges happen to be correct, but on the bottom they're not correct. So we'll do the other maneuver, which is this M slice and then the upper face and M slice again. Now we have the arrow pointed towards us, M, upper, M. We have this pattern, put it to the top right, and upper M, and now we have the arrow again, and once more we do that, and now all of these are oriented, and looking at the bottom, all of those are oriented. The next stage is to solve the last 6 edges, and the first part of that is to get the left and right pieces in place, and then we'll do the other 4. So we need this blue-yellow edge, which happens to be right here, and we need this green-yellow edge, which happens to be right here. So one's here and one's here. That's already diagonally opposite to each other in the cube. So all we need to do is rotate so that one is pointing up and one is pointing down, and then we can stack them so that here's one and here's the other. And we can put that on the bottom. So now they're both here, one here and one here. And we can rotate and slide them into place and solve. And so now this entire side is complete, this entire side is complete, and all that's left is this middle slice. And we'll do the other maneuver, which is the middle slice and then do the upper slice twice. It just happens that we have a bar already, so all of these are connected, and we just have this bar in the back. You can just put that on top and twist it around, and the cube is solved. Let's just do one more solve, but this time using some more advanced techniques. I just wanted to show you what it's like once you've learned more algorithms and have some more techniques under your belt, how much more efficient you can be. So using the same scramble, 5, 6, 7, 8, and we'll use the same colors, the blue, white to start with. The first thing that I notice is that these two are together and these two are together, and so I can just go like that to start a block. And these two can be paired very easily and put in, and so now this whole first block is done. The green-white edge can be paired easily, and then while I'm putting it in, I can finish this pair and put it in too. Then this is going to be very tricky, but these two can be paired very easily, but it will disturb these two. But that's actually fine, because as I finish this block, these will just be floating on top. I can insert these, that finishes the second block, and then I can put these back. Now, as I'm putting the first block back in place, I can either do this or I can do this. It's the same amount of moves, but if I do this instead, that flips this center. So you can always orient the center while finishing the second block. Now, it just happens that these are already oriented, which is lucky, but none of them are permuted. Normally, when this happens, you'd have to do the J-perm algorithm twice, but if you know some more algorithms, there's ways to do that in one try. Now we have the arrow case. The other bad edge is here, so I can do it in the back. And I notice that here's one of my left-right edges. So as I do the arrow, I can stack these. And I don't even need to put them on bottom. I can just put them directly into place. So the edge orientation and the left and right happen together, which is actually a common thing to do in Roux also. Then this case is a dots case. I just happen to know a little trick to finish that off. So Mr. Caden, if you've actually made it to the end of this video, I'm pretty amazed. When I first started doing this, I didn't think it was going to be a half an hour long. But if you're that persistent, maybe you're persistent enough to solve the cube too. So I'll come visit you in a couple weeks, hand you this stuff, and we'll see if we can have fun with it.